KART design will create a fountain that is aesthetically pleasing and technically intriguing. Through the design process, KART design will plan and implement the building of the fountain according to clearly defined team assignments and according to the required timeline of events.
The goal of KART Designing is to fulfill all requirements of the water fountain project to the best of our ability and within the time constraints of the set schedule. We will gain experience of working as a team to accomplish a major goal through a detailed and organized process.
The requirements of the water fountain were that water must flow against gravity, water must be an actuator, the fountain must minimize splashing, the fountain must have a 2 square foot base, the entire project must cost less than $40. The main conceptual goal, as agreed upon by the members of KART Design, was to build a fountain from reused and/or recycled materials. Since aluminum cans and plastic soda bottles are plentiful and recyclable, KART Design used the cans and bottles to design a soda fountain. KART Design decided to design and build the soda fountain because it involved each of the members' future engineering disciplines. The fountain includes the perspectives of environmental, civil, electrical, and industrial engineering. In the planned stage of the design process, all materials were gathered. The soda fountain consists of 87% recycled or reused materials. Once the materials were gathered, construction began. A hole was drilled in the side of the galvanized container for the electric cord of the pump, and the hole was sealed with RTV sealant. The hole was water tested for 24 hours and there were no leaks. The pump was secured to the bottom of the galvanized bucket and the plastic tubing was attached and threaded through the copper pipe. The pipe was used to frame and provide stability for the 2 fountain tiers. A hole was drilled in the oil pan and plastic cookie tray. The oil pan was turned upside down over the pump and the tray placed over top of the oil pan to provide a stage on which the fountain can be assembled. The plastic buckets were cut to a height of approximately 2 inches and a hole was drilled in the center. These bucket bottoms will be the tiers of the fountain. The soda bottles and cans were cut to appropriate heights. At this point, the skeleton of the fountain was complete. After the initial frame was built, some new ideas were developed and the initial design was altered. In order to reinforce the importance of recycling, we decided to incorporate the concept of a rain chain into the fountain design. The tabs from soda cans were cut and hooked together into a chain, and 4 holes were drilled in the top tier and the rain chains were attached. We decided to direct the water out of the second tier into the galvanized bucket through the use of straws. 4 holes were drilled in the side of the bottom tier and straws were inserted into the holes and bent downward. For aesthetics and soda fountain theme enhancement, soda cans were cut and hot glued to the fountain tiers. This is the first test run of the water fountain. Stability of the fountain, uneven flow rates, and water actuating movement were the 3 biggest challenges that we faced when constructing the fountain. In order to increase the stability of the fountain, a sturdier base was created out of a cut 2-liter soda bottle. Also, 4 wires were added connecting the vertical pipe to the sides of the galvanized bucket. With a new base and stability wiring, the fountain was locked in a secure position. The flow rates of the initial water fountain were uneven. Water was flowing in the top tier at 15 milliliters per second and draining at 15 milliliters per second. The top tier had a perfect flow rate. But the bottom tier had water flowing in at 15 milliliters per second and draining at 20 milliliters per second. Water was draining too fast out of the bottom tier. The flow rates were fixed by adding a tier with a smaller bottom surface area slightly above the original bottom tier. Smaller holes were drilled in the new tier and smaller straws were fed through both tiers. The smaller surface area results in a higher water level in the tier, and the smaller straws decrease the rate at which water can drain out of the bottom tier. This is the second test run of the water fountain. A requirement for the fountain was that the water must actuate movement. We decided to have water actuate the movement of 2 pinwheels. This was the final test run of the water fountain. At the 14th Annual Freshman Engineering Design Day, our water fountain finished in 3rd place.
If we were to make this fountain again, we would definitely add some type of lighting to the fountain. Also, we would devote more time to figure out ways how to reduce splashing.
The only advice that we have for future E101 students is to work hard and finish your project as soon as possible. The quicker you finish the project, the quicker you can test it. Once you begin testing your project, you will need to make a lot of adjustments. Don't wait to the last minute.